Okay, here's a thought. What if I told you that the future of advanced AI, the really smart stuff, isn't just about getting bigger, not just hungrier for data and way, way more expensive? What if the real breakthroughs are happening somewhere else entirely, in models that are actually like surprisingly small, but still incredibly powerful, almost defying what we've kind of come to expect?
That's a great question. A really great question. And it cuts right to the heart of what we're digging into today. We're going to unpack Sapient's new hierarchical reasoning model, HRM for short. And it's doing exactly that. It's directly challenging this whole idea that's been dominant for ages, that in AI, bigger is always better.
The bigger, the better assumption.
Yeah, this model, HRM, it achieves really high-level reasoning, but with a footprint, a size that's frankly tiny compared to the giants. And that could potentially change the game for how AI is developed and
Right.
deployed for everyone.
Okay, so our mission for this deep dive seems pretty clear then. We want to understand what makes this HRM thing so different, right? How does it manage to, pull off these impressive results with such minimal resources? Seems almost too good to be true. And crucially, what are the implications? The big picture stuff for AI access, for innovation. Are you ready to dive into what might actually be, well, a genuine paradigm shift?
Absolutely.
Yeah.
Look, when you survey the current AI landscape, especially, the big language models everyone talks
To
about,
GPT-4, Claude 3, those guys.
exactly. There's a very, very clear pattern, a dominant paradigm, really.
Hmm.
The bigger the model, the better the performance seems to be the rule. We're talking massive systems, models trained on billions, literally billions of tokens,
Which are basically just small pieces of text or data, right?
right, small chunks. And training on that scale, well, you can imagine it demands immense computational power, huge data sets. It's really become this sort of arms race of scale.
An arms race, yeah. That definitely captures the feeling. You just think massive server farms, huge costs. So, is anything actually emerging that pushes back on that? A different way, something that truly bucks that trend.
Precisely. And that's where HRM comes in. It's such a stark contrast, almost uh, audacious, you could
Mm.
say. We're talking about a model with just 27 million parameters.
27 million compared to billions or even trillions.
Exactly. It's incredibly lean. And get this, zero pre-training. None.
Wow. Okay, hold on. No pre-training. That's kind of nuts because usually you hear about these models needing to basically swallow the entire internet just to get started.
Right, that's the standard playbook. HRM throws it out. It's a tiny, tiny fraction of what these giants use. It's like, I don't know, comparing a super efficient electric scooter to a giant freight train. Different leagues of resource use.
So, okay, if it's that small and no pre-training, what kind of performance are we actually seeing? Does it, hold its own? Or is it just good for its size?
Oh, it doesn't just hold its own. Its performance is genuinely surprising, especially on tasks that often trip up the much larger models. HRM gets near perfect accuracy on things like complex Sudoku puzzles and maze solving, really tricky ones.
Sudoku and mazes, those sound like reasoning tasks, not just pattern matching.
Exactly. They require step-by-step logic.
Hmm.
And these are the kinds of tasks where those massive models often struggle, believe it or not, even when you try and help them with extensive chain-of-thought prompting.
Right, where you basically tell them, okay, think step by step, show your work.
Yeah, you have to guide them quite heavily. HRM seems to handle that kind of reasoning more intrinsically.
And you mentioned it was trained on only 1,000 examples. That number just sounds incredibly low, almost suspiciously low.
It really is remarkably low. But despite that tiny training set, it significantly outperformed much larger models on specific benchmarks. It even scored 5% on the ARC AGI-2 benchmark. Now, for listeners, that's a set of tasks designed to test, like real generalized AI reasoning, stuff beyond just remembering patterns.
So 5% might not sound huge overall, but on a benchmark designed for general AI from a tiny model with little training, that's significant.
It's very significant in context, yes. And on those specific tasks it was designed for, like extreme Sudoku and large 30 by 30 mazes,
Mm.
it was hitting near perfect results.
Yeah.
It's a mind-bending level of efficiency.
Okay. All right. Let's unpack that efficiency then.
Sure.
How does HRM manage this without the giant data sets, without the huge parameter counts?
Mm.
What's the secret sauce?
It really comes down to its architecture. It's brain-inspired. That's the key phrase Sapient uses. It operates with what they call a dual-timescale system. Think of it like having two different speeds or modes of thinking working together.
Okay. Two speeds.
Yeah. You've got a slow, sort of abstract planning system. This handles the higher level stuff, the strategic thinking, the what should my overall plan be
Yeah.
questions. And then you've got a fast reactive system. This deals with the immediate dynamic responses, the how do I execute this step right now?
Huh. That separation. It sounds quite intuitive, actually. Almost like how, we think sometimes. Strategic planning versus quick reactions.
Exactly. It's modeled loosely on that idea. Maybe like having a strategic CEO and a really efficient operations manager working in perfect sync.
Okay, I like that analogy. So it's not just trying to brute force the problem with scale, it's structured to think more. Maybe human-like isn't the right word, but more dynamically, in a single pass.
That's the idea. Dynamic reasoning in one go. And crucially, it doesn't need all the heavy compute that usually comes with AI training.
Hmm.
It doesn't need backpropagation through time, which is, a standard but computationally intensive training method for recurrent networks.
Right, that sounds like a technical term that usually means needs lots of GPUs.
Pretty much. And it doesn't need those massive data sets we talked about earlier either.
Mm-hmm.
This architectural elegance, this design, means it processes information super efficiently without those huge resource demands.
It's a totally different philosophy then. Instead of just scaling up, making things bigger, it's about scaling smarter through better design.
That's it exactly. Smarter architecture trumps brute force, at least for these kinds of reasoning tasks.
Okay, performance is impressive, the architecture sounds clever, but what really jumps out at me, thinking about the industry, is the economics. I mean, we must be talking about potentially massive cost savings here, right? That could have some really profound ripple effects.
Oh, absolutely profound. This is where it gets really interesting for businesses and researchers, because HRM delivers this top-tier reasoning with just 27 million parameters, no pre-training. It slashes costs, both training costs and inference costs, the cost of actually running the model,
Slashes them by how much, roughly?
to a fraction. Sapient claims less than 1% of what's typically required for those big transformer-based models.
Less than 1%, seriously.
Less than 1%. Think about that. Less than a penny on the dollar compared to the current giants.
Wow. Okay, that's genuinely revolutionary if it holds up across different applications. Are there trade-offs, though? I mean, you don't get something for nothing, usually. Is there something this smaller footprint can't do well?
That's a fair point. And yes, there are trade-offs, but maybe not the ones you'd expect. Its strength is in symbolic reasoning, planning, pattern recognition within defined structured tasks like the Sudoku or mazes or potentially logistics, scheduling, things like that. It's not designed to be a general-purpose chatbot that can write poetry or summarize any web page you throw at it. Its breadth might be narrower than something like GPT-4.
So it's more specialized.
Exactly. It's highly optimized for specific kinds of reasoning where large models can actually be quite inefficient and costly. So for its intended applications, the efficiency seems to be mostly pure gain. And the resource requirements reflect that. This isn't something that needs a dedicated data center.
No, definitely not. You mentioned, it runs in milliseconds on standard CPUs.
Yeah, standard CPUs. And get this, under 200 megabytes of RAM.
Under 200 megs. That's tiny.
It's incredibly small. That low resource footprint means you can run genuinely high-performance AI reasoning on, almost anything. Consumer-grade laptops, smartphones, embedded systems, edge devices out in the field.
Places with limited power or connectivity?
Exactly. Low resource settings where running a massive cloud-based model just isn't feasible, and you don't sacrifice the reasoning power to do it.
This really feels like it could open things up, doesn't it? I mean, if high-level reasoning can be scaled through smarter architecture, not just raw size and compute power, well, that democratizes things, right?
It absolutely does. It fundamentally democratizes access to advanced AI capabilities. Think about it. This lowers the barrier to entry dramatically for startups, for smaller research labs, for innovators who just don't have access to, millions of dollars for GPU clusters.
They're not competing in that arms race anymore.
Exactly. They can focus on innovation in architecture and application, not just infrastructure. And for industries already using AI, it could drastically cut operating expenses. Imagine deploying sophisticated reasoning at scale without the massive cloud compute bills. It really reframes the whole conversation away from this token count arms race, as you called it, towards smarter, maybe more sustainable, brain-inspired design.
A more accessible path to intelligence systems.
That's the promise, yeah.
So, given this efficiency, this ability to run almost anywhere, where do you see HRM or models like it making the biggest splash, the most immediate impact in the real world?
Well, think about anywhere. Latency is critical or resources are scarce. Real-time systems, for sure. Things like autonomous vehicles, maybe certain types of industrial automation where decisions have to be made in milliseconds.
Right. Can't wait for a round trip to the cloud.
No way. Embedded devices are another huge area. Smart sensors, medical devices, maybe even smarter appliances, things with very limited power and memory. Healthcare diagnostics is a fascinating possibility, especially in remote clinics or developing regions. Quick, accurate analysis running locally.
That could be huge.
Huge. And even in complex scientific domains. Sapient mentioned climate forecasting, apparently. HRM achieved 97% accuracy on certain specific forecasting tasks. That's pretty incredible. And robotics, of course. Giving robots more sophisticated planning and reasoning capabilities directly on the device without relying on constant cloud connection, making them truly autonomous.
So much more adaptable and useful in unpredictable environments.
Exactly. It just opens up possibilities where the size, cost, and latency of traditional large models were complete non-starters.
Okay, so let's try and wrap this up. What's the big takeaway here for you listening? Sapiens HRM seems to represent a really significant shift, maybe even a turning point in AI development. It's solid proof, isn't it, that clever architectural innovation can deliver that high-level reasoning performance without needing immense scale, without the astronomical costs. It's a powerful argument for smart design potentially trumping brute force.
It really feels like a potentially transformative moment. And it leaves us with a really interesting thought, I think. If advanced AI, the kind that can genuinely reason and plan, becomes this accessible, this efficient, so efficient it can run on common devices, your phone, your laptop, with minimal resources,
Yeah.
how does that change things? How might that fundamentally shift who gets to
Yeah.
build AI, who innovates?
Yeah, moving beyond just the tech giants.
Exactly. And where will we start encountering this kind of intelligence in our daily lives in ways we haven't even imagined yet? And maybe most importantly, what kinds of big global problems, maybe problems in areas with limited infrastructure, limited resources, could suddenly become solvable with this kind of democratized AI power?
It's a future where powerful AI isn't just for the few, but potentially for everyone.
It's a really exciting prospect to consider. Definitely something to keep an eye on.